So we're going to contrast the anatomy of the sympathetic SNS and parasympathetic nervous systems. You're going to contrast the location of the ganglia, the length of the pre- and postganglia axons, and where they exit from the CNS. And you'll also contrast that to the somatic motor pathway. Let's look at a somatic motor pathway. So we have our spinal cord. That's the anterior horn. To go to the target organ, we have a single motor neuron, and it's going to have a very long axon, and we have some telodendria at the end. Now, the thing about axons that leave the central nervous system is they're always myelinated to begin with. So let's put some myelin in. The somatic motor has a single long myelinated axon that goes to our target organ. And it can get away with that. There are only so many skeletal muscles. Yes, I know you had to memorize 305, but that's about it. Whereas think of how many smooth muscle cells you have, or glands. Here is our somatic motor neuron leaving the central nervous system, single long myelinated axon. And we're not going to worry about the neurotransmitter it releases. Now, in the autonomic nervous system, it is going to junction. And that junction is at a structure right here called a ganglia. So this is a ganglia. And it forms a chain of 2 or more neurons. Now, we're going to look at where those ganglia are found. But the reason is for this is it gets to split the signal. So, in both the sympathetic and parasympathetic nervous systems, an axon is going to leave the central nervous system. So here's a picture of the spinal cord. Here's our lateral horn. And this axon is going to leave it delayed. And it is going to not go very far till it junctions at a ganglia. Now, like the somatic motor nervous system, this axon will be myelinated. So there is the myelin right there. Now notice, it's a very short axon before the ganglia. Now the parasympathetic nervous system, that's supposed to be the brainstem. I did a horrible job drawing it. It's going to have a very long pre-ganglionic axon. And like the sympathetic nervous system, it is myelinated. Now notice, I'm not at my target organ yet. I'm going to junction into 2 axons. There's probably going to be more than 2. So there's the cell body, there's the axon. And it is going to the target organ. So this 2 is going to junction. And it's going to go to the target organ. Let's make the target organ the heart. So what do you notice? Well, this is a very long postganglionic axon. This is a very short one. And again, what's that ganglia I'm talking about there? So, if you remember the previous chapter, a ganglia is just a collection of cell bodies outside the central nervous system. Well, it leaves the central nervous system here. So here are cell bodies outside the central nervous system. And the ganglia lets us junction. So here is the cell bodies outside the central nervous system. It lets us junction. Now the axon before the ganglia is called the pre-ganglionic axon. So this is the pre-ganglionic axon. This one is before the ganglia. It is the pre-ganglionic axon. Notice they both have myelin. Now the axon after it is called the postganglionic axon. So if we go over here, so these myelinated axons are the pre-ganglionic axon. So I'm going to write pre. So those are the pre. Then these axons over here, P-O-S-T, are the postganglionic axons, and there's the ganglia. So what the heck is a ganglia? Well, it allows for junctioning. So we're going to have some junction right here. We'll call this the lateral horn. So one motor neuron coming down the spinal cord is going to junction to two. They're going to go out into something called a right ramus and junction in the ganglia. And if both of these junction into two axons, I suddenly have 4 axons coming out instead of 2. So it allows for divergence. This is the splitting of a signal, and that's why there are ganglia. There's so many muscle nerve fibers, cardiac muscle fibers, smooth muscle nerve fibers, glands, that you cannot have one axon going out of the spinal cord to innervate them all. There's just no room in the central nervous system. So, let's look at where they exit. The sympathetic nervous system is going to exit through the thoracic nerves, 1 through 12, and the lumbar nerves, 1 and 2. So the sympathetic exits T1 through L2. So the parasympathetic nervous system exits from the brainstem. Remember I said I have a horrible picture of the brainstem there. So, and technically this is not the brainstem, that's going to be the mesencephalon. The parasympathetic nervous system exits cranial nerves 3, 7, 9, and 10, as well as S2 to S4. So it doesn't have as many exits as the sympathetic nervous system does. So the preganglionic axon, again, is going to the ganglia. And we're actually going to ignore this middle one right here for now. The cell bodies are in nuclei in the central nervous system, either for the sympathetic division, L2 from T1 to L2, for the parasympathetic, 3 cranial nerves, and S2 through S4, and the cranial nerves. Now, if you look at both of these pictures, we have myelin in the preganglionic axon. So if I ask you, is the preganglionic axon myelinated or not? The answer is, it is myelinated. Now, in the sympathetic division, it is a short preganglionic axon. The ganglia is actually near spine. For the parasympathetic nervous system, the ganglia is at the target, so it has a long preganglionic fiber. Now we're going to see the opposite for the post, the fiber after. Since this is at the spine, it has a long postganglionic fiber. Since this is at the target organ, it's going to be short. Now the postganglionic axon is always unmyelinated. So this fiber leaving the parasympathetic one, that is an unmyelinated one. The fiber leaving the sympathetic ganglia is always unmyelinated. Now the way I remember this is my favorite cranial nerve 10, the vagus. The vagus leaves the brainstem and goes all the way to your liver. That's about 24 inches, give or take a few inches. So that's going to be a long preganglionic fiber. It's going to be a couple feet long. But once it's at the liver, the ganglia is in the wall of the target organ. It doesn't have to go far. Whereas you have the sympathetic division, which leaves T1 to L2, and you actually have some fiber, and it goes to the spinal cord. So that's going to be a short distance. Now you have some fibers leaving the ganglia going all the way up to your eye. That's going to be about a foot. So it's going to be a long postganglionic axon. Which one of these had the wall? Which one of these had its ganglia on the wall of the target organ? Well, we have the sympathetic and the parasympathetic. It's not going to be both. It's not going to be neither. So the parasympathetic, we have the vagus, cranial nerve 10, going all the way down, myelin, and then its ganglia is near the wall of the heart. That really is a heart there. Or we have the parasympathetic. It's going to go short pre, there's our ganglia, long post. So which one had the ganglia on the wall of the target organ? Oh yeah, it must be parasympathetic. Short preganglionic fiber. So there's our heart again. We have our parasympathetic right there. There's our very long preganglionic fiber, because that's the vagus, of course, my favorite nerve, where we have our, so that's PSNS. Then we have our SNS. We have our axon going a very short distance to the spinal cord. And we have our postganglionic axon going to the heart. So which one has a short preganglionic axon? Well, it must be the sympathetic nervous system because the ganglia is near the spine. So which one had the short postganglionic axon? Well, I don't want to redraw my picture, so let's go back. Oops, too far. Here is our heart, parasympathetic nervous system, vagus, long preganglionic, short post. So it must be parasympathetic.